In section 6 of chapter 7, we're going to still deal with radicals in exponent form, and we're going to start doing some more operations and analyzing and reflecting on some of the rules Mr. Sill told you previously about what you can and can't do with radicals, and now potentially understanding why you can and can't do them with radicals, because we're going to start understanding them as fractions. I only got one side of notes. I'm only going to do 2 problems. Even though you see 4 on there, you might notice that it's the same problem twice. Problem number 1. I'm going to solve that sticking with radical notation. If you have 3 times the 5th root of the quantity 2x quantity to the 4th power minus 9 times the 5th root of the quantity 2x quantity to the 4th power. What I told you previously is you can only add and subtract 2 terms that have radicals if the indexes of the radicals are the same and the parts underneath the radical are the same. In problem number 1, they are. They're both the same type of radical. So I could imagine that as 3x minus 9x, which leaves me with negative 6 times whatever the radical is. It is important that you recognize that that rule still applies to fractional exponents. You can only combine terms that have fractional exponents if and only if the fractions are the same and the part that the power is associated with is the same. So problem number 1 in blue, they both have a 4/5 power and they are both being brought to the 2x. Since these are the same, I can now combine these 2 terms together. This is just 3 minus 9, which is, again, negative 6 times 2x to the 4 over 5. This is largely just to showcase that the rule that we had for adding and subtracting radicals is the same thing as adding and subtracting with fractional exponents. But number 2 is where things get a little more interesting, a little more spicy. Because for problem number 2, I have the 3rd root of x squared times the 4th root of x to the 5th. And what I said previously, spoiler alert, was a lie. I said you could only combine 2 radicals together through multiplication if they have the same index. That is to say, you could only multiply a square root with another square root, or a cube root with another cube root. That's wrong, kinda. You can only combine them together in their fractional form. You cannot combine them together when they're in radical form. So for problem number 2, nothing can be done. You can't do anything with that. But as soon as I switch that to fractional exponent form, there's plenty we can do. Because this is the same thing as something like x squared times x to the 3rd power. All of you recognize that that's just x to the 5th because we take the powers and add them. As long as the bases are the same, if you are multiplying, we simply add the exponents. The bases are the same. They're both x. We're just going to take the exponents and add them together. This is just x to the 2 over 3 plus 5 over 4 power. And we know how to add fractions together. You just need to get a common denominator. So the common denominator between 3 and 4 is 12. So I multiply this fraction on top and bottom by 4. And I multiply this fraction on top and bottom by 3. And that'll leave me with x to the 8 over 12 plus 15 over 12, which is x to the 15 plus 8 is 23 over 12. And that would be my final answer. Or, if you so choose, you could write that as a radical, the 12th root of x to the 23rd power. And that is actually what this would have simplified into if you'd done some fancy manipulation involving radicals. You could combine them together into this. And this is how you can combine 2 radicals together through multiplication. In fact, this works on all radicals. Now that rule about 2 radicals being multiplied together have to have the same index, that doesn't exist anymore for you. You just have to convert it to fractional exponent form.